Now, the last thing that I want to show you here is how to use copy constructor. So we already saw the syntax when we looked at copy constructor. E2 is an object that is already constructed. E3 is a new object that we are trying to construct. And we will use E2 to initialize E3. So in this case, a copy constructor will be called. First, a new object E3 will be created and E2 will be copied into E3. So let's continue and then let's look at the print. Notice now we see that the copy constructor was called. That's good. Now let's look at another way of calling copy constructor. Now I've written a function called pass by value and I'm passing our object which is of type employee to this function pass by value. Now let's go to the definition of this function. Since it's passed by value, I'm passing this parameter as a value. Now when I pass the parameter as a value, what happens is first E3 is an object of type employee that is already created, and we are now trying to create this temporary object EMP, which is going to be initialized with E3, which is already in memory. So this again should call a copy constructor. So let's put a breakpoint within this function and let's hit continue. Notice now again a copy constructor was called. This time the copy constructor was to initialize this local variable EMP, and within this function I'm just printing pass by value and the name of this copied employee. Since we're copying it from Bob, the name should still be Bob, so let's continue. Okay, now notice Bob is the name of the employee and we see pass by value being printed. Now at the end of this function call, this temporary object EMP should be destroyed. The role of the temporary object, scope of the temporary object was limited to this function. So once the function call ends, this temporary object is deleted. So when you pass by value, a copy constructor will be called at the beginning and a destructor will be called at the end. Now instead, if I pass it by reference, let's see what happens. Now let's remove this breakpoint and hit continue. Now notice no constructors or destructors were called so far, so that's good. We are only saying that EMP is an alias to the object that was passed to this function passed by reference. And now again I'm printing the name of the employee, so we're still passing E3, so name should be still Bob. Also at the end of the function call, we didn't destroy any objects, so that's good. Now the only thing that one probably needs to modify here is to make sure that this is a const, so that we won't accidentally modify this reference that we are passing to this function. Suppose we want to modify the employee that we are passing, then we can remove the const. Okay, now let's go ahead. Okay, now finally this is a new syntax that shows you how to construct an object. Here again a copy constructor will be called. So the syntax is employee, which is the data type, E4 is the new employee that we want to create, and we are using E3 to initialize E4. So you can use this function call operator and pass E3 as the parameter. And this time again we are using an already constructed object E3 to initialize a new object E4 that is going to be constructed. So this will call the copy constructor. So let's continue and check what will be the print. And notice again the copy constructor was called. Now finally, I want to show you how to use stdcout and print user defined data types. Now previously we were using cout to print inbuilt data types. So there was this operator which was overloaded by C++ for us to support printing of inbuilt data types. Now with user defined data types, C++ will not print our employee directly. We need to overload this operator and then let C++ know how to print our employee objects. So suppose I write syntax like in line 218, which will use cout to print a newly constructed employee. How should we overload this less than operator? So first let's see the definition of this overloaded function. Notice again, this is an operator. So the syntax for this has a specific name. So operator is fixed followed by whatever is the operator we are overloading. So since less than is the operator we are overloading, the name of the function is operator less than. And now we have two parameters that we are passing to this operator. The two parameters are the two operands that are the two operands for this operator less than. Now, since we are declaring this function outside the class, we need to provide both the operands as parameter to this function. Suppose this was declared within the class, one of the operands is pointed to by this pointer, so you don't need to pass it. The second one is the right hand operand that needs to be passed as a parameter. Since this is declared as a global function outside the class, we need to pass both the operands as parameters to this function. Now the left hand operand is of type OStream. So cout is of type OStream. I'm passing it as a reference. Name of the variable now is OS. So OS is just an alias to cout. And the second operand is of type employee. So the second operand emp, which is again a const reference, is an alias to this employee object that we were passing and printing. Okay, so far I hope this is clear. Now the return type again is an OStream reference. Now why the return type is OStream reference is because, so first we are looking at this part of this expression where cout less than employee is printed. Now once we are done with this function call, notice we are chaining this operator less than to print additional things. So now the return value of this first less than should return again an OStream ampersand, so that the left hand operand for the second less than operator is still of same type, which is OStream reference. So the return type from this function is OStream reference. Now within the function, we can use the get methods from our class to get the name, position, pay rate, and location of our employee. Now these methods get name, get position all return a default data type, which is either a string or an integer. So we can use less than directly to print them like how we were doing before. Now instead of cout, we will use OS to print these. And since OS, we pass cout to OS, OS is just an alias to cout. So at the end of this print statement, we can return back OS, and this will help us to print our employee onto the terminal. So let's continue and check what will be the print. Now notice parameterized constructor was first called. This was called to construct this local object here, and then we use the overloaded operator to print the employee onto the terminal. So this is great. So whenever you create your own classes, and if you want to print an instance of your class onto the terminal, you need to overload the less than operator, and then let the C++ know how you want to print an instance of your class. Now notice again a destructor was called at the end of this call. The reason why the destructor was called was because this variable, this was a temporary employee that we were creating, which was only used to print. Once we print the employee's information, the employee can be destroyed. Now suppose you don't overload the less than operator, then you will get a compilation error. Okay, so now finally we can go to our employee management system again. So let's now start designing our employee management system, this time by using our employee class. So now I can create a vector of employees. So in each, so in my vector, each element is now of type employee. And since our employee class encapsulates all the information of an employee, which is the employee's name, position, pay rate, and the employee's salary, we only need one single vector to store the information of our employee. So we have only one variable employees, which holds all the employees that are part of our organization. And now I'm using braces to initialize the employees of our organization. There are 5 employees to begin with. Their name, position, space, location, and salary is provided. So here I'm using parameterized constructor to construct these temporary employees, and I'm pushing them to the vector, or I'm constructing a new vector which will have these employees initialized. So let's look at the print. Now notice a lot of things happened. So there were 5 parameterized constructor calls, then there were 5 copy constructor calls, and again 5 destructor calls. The 5 parameterized constructor call should be evident. So that's because we are creating these 5 temporary objects using parameterized constructor. The 5 destructors should also be clear. The 5 destructors are because we are creating these temporary objects only to initialize our vector. So once the initialization is completed, we need to destroy these temporary objects, so the destructor will be called. Now to fill our vector with these temporary employees that we have created, a copy constructor will be used. So since the temporary employee is already created, and now within our vector we want to create a new employee and copy the information of the temporary employee. To do this, the copy constructor was called. So notice again 5 copy constructors were called. Now we can use the method print underscore employees to print our employees onto the terminal. So previously, with our previous design, we used to pass 4 different vectors to print underscore employee function. Now notice we are only passing 1 vector, and this already simplifies. We won't have problems like passing the name instead of position and juggling with orders, and such bugs will already be eliminated with this approach. Now within this function print underscore employee, I'm using the range based for loop iteration. So we looked at this in the previous class, wherein you can access each employee that is part of this employee vectors and then print it onto the terminal. So since I've already overloaded the less than operator, I can directly print an employee with just this small syntax. So this is much more cleaner way of printing an employee. We're just passing 1 single vector. We've overloaded the less than operator. Now we can directly print our employee with this small piece of code. Again, notice I'm passing the employees as a constant reference, so we will not be allocating and deallocating memory from this function call. This is only an alias to the vector that was passed. Okay, so once we print all the employees, we will see what happens. Let's go back first. Notice no additional constructor or destructor was called. All we are doing is looping through each employee and printing the employee's information. Okay, now let's look at how to hire a new employee. To hire a new employee, we had this method called add underscore employee. Now previously we were passing 8 parameters to this function. Now we are only passing 2 parameters. The first parameter is a temporary object that will describe the new employee. Second parameter is our vector, which holds all the employees in our organization. Now again, the definition of this function will be very simple. It's only 1 single line. We are using push underscore back method to push this new employee into the employees vector. Notice again we are passing our temporary employee as const reference, so no copy constructor. The second one is passed as a reference because we are modifying it by using this pushback method. And since we are using pushback, we will call copy constructor to copy this temporary object that is passed to create new object within our vector. So when we go ahead and continue our program, we should see that a new copy constructor will be called to add our new employee. So first let's look at the size of our employee. Notice the size is equal to 5 right now. So first let's continue and add 1 single employee. Now notice a lot of things happened. So all we were doing is creating a temporary employee, adding it to our vector, and then returning back from the function. So you would expect a parameterized constructor to be called, and then a destructor to destroy this parameterized temporary object that was created. And then one single copy constructor to copy this temporary object into our vector. However, there were 6 copy constructor calls and then 6 destructor calls that happened. Now the reason why this 6 copy constructor calls happened is because our vector initially had size which was equal to 5. Now to create a new position, C++ needs to first resize our vector, that is, it needs to allocate enough memory to hold the 6th element, and then once the memory is resized, C++ will copy all the previous elements back into the new allocated memory and then add the 6th element at the end. So this caused this additional 5 copy constructors to copy the previous elements after resize, and then the last element was added. So this additional copy constructor and destructor can be hidden. Since we don't know what happens, we are not even overloading this copy constructor method in our programs. There could be a lot of additional overhead that can happen due to this additional copy and destruction. So it's important to pay attention to these small things, as in when your program becomes big or you're working on a bigger project, these minor points can lead to major issues. So for example, let's think about this for a second. Let's think that we are creating this employee management system for Amazon. Amazon has 1 million employees. Now with 5 employees, we saw that 5 different copy constructor calls were called. Now for each new employee you add, this will become a summation, and so as n increases, the number of copy constructor and destructor calls will be almost polynomial in square. So if you have 1 million employees, then you will have 1 trillion copy constructor and destructor calls that will be made to add new employees. So this can be catastrophic. Something as simple as this, if is not thought about when we are writing classes, can lead to performance issues that can be very bad. So it's very important to think as a programmer when we are coding, what are the things that can be internally called by C++ and how we can optimize it to reduce these additional overheads. So now let's go ahead and let's add a new employee.